Hello, and today's purpose of the day is I can solve rational equations. Let's take a look at some vocabulary. Rational equation. A rational equation is an equation containing one or more rational expressions. This was a word that we have seen and heard before, so please right now jot down what you remember to be a rational equation. Great effort! Some of the examples I came up with were a complex fraction, which would be a to the fifth b over c divided by d squared over j. That would be an example. A mixed expression would also be an example, such as 4 plus 5 over x minus 3, or just a fraction containing variables or numbers, which could be x over x minus 2. So those are three examples of a rational equation. When a rational equation is a proportion, you can use cross multiplication to solve. For example, 5 over 10 equals x over 8. This is a simple fraction equal to a fraction that we could use cross multiplication, but the same applies for a rational equation. So what we would do here is take 5 times 8, set that equal to 10 times x. So 5 times 8 is 40, and 10 times x is 10x, divide by 10, so obviously here x equals 4. So an example of cross multiplication. Let's take a look at a few examples. What would you do here? Think about this for a moment. Great job thinking about that. Well, if you remember from the last slide, if you have a rational equation that's a proportion, which basically means a fraction equal to a fraction, you can use cross multiplication to solve. So here we could take 7 times x plus 1 and set that equal to 3 times x minus 3. So what we would get with that would be 7 times the quantity x plus 1, set that equal to 3 times the quantity x minus 3. Now we just have to do a little bit of math, distribute, and get 7x plus 7, set that equal to 3x minus 9, and then continue to solve. So here I would maybe perhaps put the x's on the left-hand side by subtracting 3x, at the same time subtracting 7 to get that on the other side. So I get 4x is equal to negative 16. So here x would be equal to negative 4. So again, cross multiplication works when you have a rational equation that's a proportion. Let's look at another example. Now, if you don't just have a proportion, you are going to have to find the LCD, which stands for least common denominator. Then we will have to multiply both sides of the equation by the least common denominator so that you have a common denominator. So let's take a look at this example. You can tell this is not a proportion equal to a proportion because of this negative 2. It's not a fraction equal to a fraction because we have that minus 2. So we are going to have to find the LCD, least common denominator. So I'm going to put this 2 over 1. So if I look at all the denominators, I have x minus 2, 1, and x plus 2. I need to find the common denominator of those three. And that common denominator is x minus 2 and x plus 2. So what this x minus 2 needs is to be multiplied by the LCD. So x minus 2 and x plus 2. Now, why that's beneficial is because now I can cross out the x minus 2's because those two together just cancel each other out. Then this minus 2 right here needs an x plus 2 and x minus 2, and nothing cancels out with the 1. And then over here, this one obviously needs the same thing, x plus 2, whoops, let's fix that, x plus 2, x minus 2. So what cancels out are the x plus 2's. So now I have to go ahead and I have to do a little bit of math and simplify. So what I have here with the first rational expression is 2x minus 5 times the quantity x plus 2. And I'll worry about simplifying that in a moment. Here on this other rational expression, I have 2 times the quantity, x plus 2, x minus 2, and I need to be careful and keep that all in parentheses. And then that equals here this third rational expression, which in the numerator says 3 times x minus 2. Now, why was that important to get rid of or to get a common denominator? Well, then I could get rid of the denominators, and I didn't have to worry about them anymore, and I just have to worry about the numerators, which makes this problem so much more easier now. So I'm going to go through and do a little bit of math. So I'm going to FOIL these here. What I end up getting is 2x squared plus 4x minus 5x minus 10. Here, x plus 2 times x minus 2 is x squared minus 4 times 2 would be minus 2x squared, because this negative distributes here, and a plus 8, because 2 times negative 4 is negative 8, times a negative here, which would be positive 8, and that equals 3x minus 6. Now I'll continue to simplify here, and I see the 2x squareds, cross that out better, cancel out with each other. And then I see 4x minus 5x here gives me a negative x. Negative 8 plus, or excuse me, negative 10 plus 8 gives me a negative 2 equals 3x minus 6. Get the x's on one side. Get the numbers on the other. And I get negative 4x equals negative 4. Solve this for x here and get x equals 1. Now I can go back and plug this in to the original equation, this rational equation up here, and make sure it works to check my answer. All right, let's take a look at one more example here. So I do not see a proportion with this rational equation, so I can't use cross multiplication. So then what I need to do is I need to figure out the LCD, least common denominator, and multiply it by every rational expression so that I can get rid of my denominator. So what's the LCD of n plus 3, and n times n plus 3. You got it. Great job. So I'm going to multiply each expression here by n and n plus 3 and see what cancels out. So here the n's cancel out. Here the n plus 3's cancel out. Here the n's cancel. So then I have left n plus 3 times n plus 2 plus n times n plus 5 equals negative 1 times the quantity n plus 3. Now I can go ahead and simplify, and I can FOIL here and get n squared plus 2n plus 3n plus 6. Distribute here, plus n squared plus 5n equals negative n minus 3, because I have to distribute that negative. Now if I simplify some like terms, I have n squared and n squared to give me 2n squared. 2n plus 3n is 5n, plus 5, another 5n is 10n, plus 6 equals negative n minus 3. And I do see a quadratic here, so I do want to try to get everything on one side and get this equation equal to 0 so that I can solve then for n. So I'm going to add n here and add 3. And so I get 2n squared plus 11n plus 9 equals 0. I'm going to use the snowflake method to find factors of 18 that when added together give me 11. And that would be 9 and 2. And I could simplify this over here to 1 and 1. So I get n plus, 2n plus 9 and n plus 1 equals 0. So set the two factors equal to 0. So I end up getting n equals negative 9 halves as well as negative 1. So I get two solutions here, and I can keep both solutions. I will not have any that will not work when I plug them back in. But again, to check your answer, you could plug this back in to make sure that they do work out. Thanks for listening. See Schoology for more information. Have a great day. Bye.